continuing. So let's say we want to basically compute using four-step rule. So there are four things that you have to do. So let's say we're given y is equal to f of x. So we want to substitute x plus delta x for x. So it's this one. Rewrite it as that. And then y, you replace it with y plus delta y. So we have this. And we solve for y and delta y. So we'll get to that eventually. It's gonna make more sense once we solve practice questions. So yeah, you rewrite this entire equation like this. Basically transpose y to the other side, and then you divide the equation by delta x. By the way, y can be rewritten as f of x. So as you can see, it's exactly the same as that. So you find the limit on both sides of the equation as delta x approaches 0. So dy over dx is equal to the limit as delta x approaches 0, delta y over delta x. And then just copy this. So it's either that, you find the limit, or you could use a definition of derivative. It's essentially the same thing. In some textbooks, they, instead of writing delta x, they write h. So this could be rewritten as that. Okay. So teaching you the rules are, it's basically not the best way to learn. Let me demonstrate it through sample problems so it makes more sense. Let's say we have this function. So the derivative of f of x is equal to the limit as x delta x approaches 0 of, let's see, okay, so we substitute x, we replace it with x plus delta x, right? So this entire thing is going to look like this. Delta x again can be rewritten as h. They're essentially the same thing. And then and then and then divide both sides by delta x. Then you find the limit. could use FOIL method. By the way, once we transpose y in the right side, we'll have this. We just copy that coming from here. The exact question we started with. We literally just copy. And then simplify. Something don't look right. Don't forget the delta x. So cancel. This, by the way, is dx. My apologies. Let's try solving this normally. Okay. So the derivative of this function is 4x minus 5. If we substitute directly, so delta x is 0, we end up with 4x minus 5. This is the answer. So you go through all that just to find the derivative. So clearly, four-step rule is a pain, but it is part of differential calculus. So pick a struggle. Just kidding. We'll do this later. The solution for this is pretty long. Let's try this first. So replace simplify. Y is x squared minus 5x coming from here, right? We can't simplify anything, we just copy. And then this time, bring this to the other side. And then we find something to cancel. Divided by delta x. Okay, so when we start substituting, so we have 2x minus 5. That's the final answer. Let's try to solve it using the normal way. So derivative, bring down power rule. It's exactly the same. So yeah, next. Try to merge the fraction. You might be tempted to think that we just have to put plus delta x here so that the denominator is the same, but no, that's not how you do it. You do this. So we have that. Further simplify. Also simplify the denominator, unfortunately. So what's the next step? We divide both sides by delta x. Actually, we can rewrite this as like that. So distribute in the denominator the delta x. Whatever's in the numerator remains the same. Combine like terms. Actually, we don't have to distribute. We can cancel something. And then we find the limit. So substitute directly. We end up with 0 over... Oh wait, no. X is different from delta x, okay? So we don't touch x. We can rewrite this as like that. So let's check our solution. Let's use quotient rule. So as you can see, they're the same. Okay. One more example. Let's try 2 more. Each is going to be a unique kind of question. Try this. So and then divide both sides by delta x. So what do we want to do now? We want to rationalize. I think we can simplify now. Directly substitute. So it's going to look like this. That is the final answer. Another one. Let's try trig this time. So y is equal to sine x. It is understood that the derivative of sine x is always going to be cosine x. Actually, that is one of the lessons we'll have in the upcoming videos. So it's a list that you have to memorize. It's a lot to memorize, but eventually, by answering many practice questions, you'll get used to it. It's gonna get stuck in your mind eventually. So let's just try. Four-step rule. We already know that the answer is cosine x, but how do we get the same thing using four-step rule? So let's start. Okay, you need to know this in order to solve in this part. So what you have to do, if we have something sine and then a plus b, it's gonna be written as sine a cos b plus sine b cosine a. You have to know this. So how do we apply that here? So sine x cosine delta x. This is a, this is b. Okay. And then what do we do now? Okay. There's also another thing you have to know. Sine h over h is equal to 1. Cosine h minus 1 over h is 0. So how do we apply those here? We have to do the opposite of merging the fraction. In other words, let's do this. So sine x, let's exchange these positions. Cosine delta x minus 1 coming from here, and then sine delta x cosine x. So from there we can rewrite this one as cos h minus 1 over h, because again these are the same. So let's set the b equal to 0. How about the other side? Sine h over h and then cosine x. That's supposed to be equal to 1. So we have cosine x times 1. And then anything that's multiplied to 0, well, that's 0. We have cosine x instead. So cosine x is the answer. And how about the other way around? Let's try y is equal to cosine x. We want to find the derivative of it. So I'll spoil you the answer already. It's by memory, it's supposed to be negative sine x. Don't forget the u over the x. Where's that? But why didn't we apply d over dx in this case? Well, it's just x. The derivative of x is just 1, so it doesn't change anything. But this is what we have to know if ever, let's say, we have sine x squared. So in that case, it's going to be cosine x squared and then d over dx. The derivative of what's inside the parenthesis, that's going to be 2x. We can rewrite that as 2x cosine x squared. Okay? Proceed. Okay, another thing. So let's say cosine a plus b, right? So we have cos a, cos b minus sine a, sine b. It is what it is. Memorize it. And also, cos h minus 1 over h, again, that's equal to 0, right? Sine h over h is equal to 1. How do we apply that here? So cos a, cos b minus sine a, sine b. Now, what do? We can interchange the positions of these two. Whoops, bad handwriting. No wonder I got confused. It's supposed to be y. Sorry. I got confused the second time. That's supposed to be x, not y. Okay? Cos h minus 1 over h. It's this one. So we have cosine x times 0. Sine h over h. Sine x times 1. Therefore, this is 0. This is going to be just sine x. Therefore, the answer is negative sine x. Okay, that's it. We're done with four-step rule, I believe. Are we? Let's just ditch four-step rule at this point. Let's answer a few more practice questions using normal derivative. So, the normal way, the easier way. So, quotient rule. Okay, and then we can cancel these two. The radical, we can transform it as this. We can cancel 2. So the same base, but well, in that case, we'll just add the exponents. So 1/2 plus 2/2, that's gonna be 3/2. So that is the derivative. Okay. What else? We can rewrite that as if we reciprocate, we'll have something like this. Am I still going through the right path? I can't tell. There's an easier way to solve this actually. Let's try that. So we let whatever is inside the radical sign u equal to u. So therefore, we have something like this. When we want to find a derivative, it's going to be I think we forgot to find the derivative of whatever's inside. Let's do it exactly that. So du over dx, how do we find it? We use quotient rule. So okay, so that's that. Let's try placing it here. Let's see what happens. Okay, screw that solution. Let's actually restart using this. I mean, we'll continue from this. And then okay, that is the final answer. Disregard this is correct. Like I said, if you can simplify your solution, best do that before it gets a lot more complicated. Because if you don't take the easiest routes, the tendency is you risk getting it wrong. So that's what happened in what I did earlier. You could just simply use this method. Just if something is pretty complex already, you rewrite it as u first, and if you want to find u over dx, you solve it separately. You don't write it in the same solution, or it's gonna be really long. It's gonna intimidate you. Okay, this could be the final answer already. if we don't have to reciprocate. Okay. Um, we can use product rule, or we can just simplify. Uh, my my personal decision is we solve through product rule. So something doesn't look right. Ah, my eyes. I thought this was negative because of the way I encircled. So we have 108 cube. U cube. So that's the answer. Next question. Okay, my intrusive thought started to. Let U is equal to be that, whatever's inside the radical sign. So or basically you want to look for U. So quotient rule. Maybe not factor. I can't guarantee if my answer here is correct. We've answered many practice questions already anyways, so I'll leave this to you. Okay. That's what I was missing. Damn. For that matter, let's recalculate. Oops. So yeah, that's the answer. That is the answer. That's it for this video. Next one will be on trig identities, inverse trig, hyperbolic, uh, what else? That kind of sort. We mix it with derivatives. Also, exponential and logarithmic functions involving differentiation to those things. Ln method. There's one more. Implicit differentiation. So, yeah, that's it. Thanks for watching.